Ever wondered what exploratory data analysis is and why it holds significant importance in data science? Well, let's demystify that for you. Exploratory data analysis, or EDA as it's often called, is a process used to understand and summarize data sets. It's like peeling back the layers of an onion, discovering the hidden patterns, spotting anomalies, or testing a hypothesis. But here's the kicker. EDA isn't just about understanding data. It's about understanding it in a way that's visual and intuitive. Think of it as storytelling for data science. It's about creating a narrative that brings the numbers to life. And let's not forget, EDA is a crucial first step in the data analysis process. Without it, we'd be like detectives trying to solve a case without examining the evidence. It helps us make informed decisions about the next steps in our data journey. So, now that we know what EDA is and why it's important, how about we delve into the process? Diving into the process of exploratory data analysis, we can break it down into 4 key steps. The first step is data cleaning. This is a crucial step where we prepare our data for analysis. It's similar to cleaning your kitchen before you start cooking. Just as you wouldn't want to cook with dirty utensils, you wouldn't want to analyze dirty data. In this step, we deal with missing values, inconsistencies, and outliers in the data. It's all about ensuring that the data is accurate and reliable. Next comes data wrangling. This is the process of transforming and mapping data from its raw form into a more appropriate and valuable format for a variety of downstream purposes, such as analytics. It's like kneading dough into a perfect ball before baking. We might need to combine data from different sources or reshape it to make it suitable for analysis. The third step is statistical analysis. This is where we start to dive deeper into the data. We use statistical methods to identify patterns, relationships, and trends in the data. It's like tasting your food while cooking, adjusting the flavors based on what you discover. We might use measures of central tendency like mean, median, and mode, or measures of dispersion like variance and standard deviation, among others. The final step is data visualization. This involves creating visual representations of the data. It's like plating your food attractively before serving. We use charts, graphs, and other visual tools to present the data in a way that is easy to understand and interpret. This allows us to see the big picture, identify patterns and trends, and communicate our findings effectively. In essence, these steps are like a recipe for understanding your data. You clean your data, wrangle it into a usable format, analyze it using statistical methods, and then visualize it to understand the patterns and trends. Each step is crucial and builds on the previous one, leading to a comprehensive understanding of the data. These steps provide a roadmap to understanding the data and extracting valuable insights from it. You might be wondering, what does this look like in a real-world scenario? Let's dive into an example. Suppose you're a data scientist working on a project to predict house prices. Before jumping headfirst into building a predictive model, you'd first use exploratory data analysis, or EDA. You'd start by summarizing the main characteristics of your dataset, maybe through visual methods like graphs or charts. You'd examine variables like the size of the house, location, and the number of rooms, identifying patterns and spotting any outliers. Perhaps you notice that houses in a certain location are priced unusually high. With EDA, you can dig deeper, asking questions like, is it due to a trend in the real estate market, or is it a data error? This process helps you understand the data, improving the quality of your predictive model. As you can see, EDA plays a crucial role in understanding the data and making informed decisions. So, to wrap things up, we've embarked on a journey through the fascinating world of exploratory data analysis, or EDA for short. We've learned that EDA is a crucial aspect of data science, serving as the first step in our quest to unravel the mysteries hidden within our data. It's here where we get our hands dirty, diving into the dataset, identifying patterns, spotting anomalies, and formulating questions that will guide our future analysis. We've walked through the process of EDA, which begins with data collection and cleaning, progresses to visualization and transformation, and culminates in the modeling of our data. Along the way, we've seen how this process can be applied practically, helping us to make sense of complex datasets and draw meaningful conclusions. In the end, it all comes back to exploration. Remember, exploratory data analysis is your first step towards understanding your data and making it meaningful. So next time you're faced with a dataset, don't forget to explore.